With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hi, in this question it is given that a point source is emitting 0.2 watt of UV radiation at the wavelength of this. We can see lambda is equal to 25 and 37 angstrom. This source is placed at a distance of 1 meter from the cathode of the photoelectric cell. We can see the cathode is made up of potassium. Work function is given of potassium, that is equal to 2.22 electron volt, and has the surface area is this 4 centimeters square. We can see clear. Now in the first part of this question, according to the classical theory, what time of exposure to radiation shall be required for potassium atom to accumulate the sufficient energy to eject photoelectron, assuming that radius of each potassium atom is this 2 angstrom and it is absorbed all energy incident on it. Clear. Now in the first part of this question, we have to find this time. We have to find. Clear. So in this question it is given that this work function is equal to, we can see 2.22 electron volt is given. Clear. And this is equal to 2.22 into, we can write 1.6 into 10 to the power minus 19, we can write, and this is equal to 3.552 into 10 to the power minus 19 joule, we can write. Clear. This is what work function we can see, and r is given, that is equal to 1 meter. We can see from here. Clear. Distance is given, that is equal to 1 meter. Clear. So this is what 1 meter we can see. So we can find the intensity. Clear. So how we can find the intensity? We can see from here. Intensity is equal to W and divided by 4 pi r square, and this W is given, this is equal to 0.2 watt. Clear. So 0.2 and divided by, we can write 4 pi r is what 1, so 1 square. So this is what intensity we can see. Clear. This is what joule per meter and per second, per meter square and per second, we can see this is what intensity. Clear. Now area, we can find the potassium. So potassium area is equal to, we can see pi r square. So this is equal to pi r is 2 angstrom. So 2 into 10 to the power minus 10, this whole square. So this is equal to 4 pi into 10 to the power minus 20, we can write. Clear. Meter square. So this is what area we can see. Now we have to find the time. Clear. So how we can find this time? So this time is equal to, we can see from here, this is equal to 3 point this 5, we can write energy work function. So energy by power is equal to what? Area, we can see. Clear. So energy is what we can see in the joule, 3.552 into 10 to the power, we can write minus 19, and divided by, we can write this power. So power is equal to what? We can see from here, this power is equal to again intensity into area. So intensity of this area, intensity into this area. So intensity is what we can see from here, 0.2 and divided by, we can write 4 pi this, and we have to take this area. So this area is what? 4 pi into 10 to the power 20, we can write. Clear. So in this way we can find the time. So time is equal to, we can see from here, 178 second. Clear. So this is the time you can see. Clear. So this is the answer for the first part of this question. Now in the second part we can see, so in the second part we have to find the energy of the single photon. We can see in the second part, we can see photon flux is defined as the number of light photons reaching the cathode in the unit time. Calculate the photon flux. So B part we have to find the photon flux, we have to find. Clear. So how we can find the photon flux? So for this, first of all we have to find the energy of the single photon. So this is equal to what? Hc and divided by this lambda. Clear. So H we know, this is equal to 6.23 into 10 to the power minus 34, this, into C we know 3 into 10 to the power 8, this, Hc and divided by lambda. Wavelength is given, this is equal to 25 and 37. 2, 5 and 3, 7 we can see. 3, 7 into 10 to the power angstrom. So minus 10 we can write, clear. So after solving this, we can find this is equal to 7.84 we can write into 10 to the power minus 19 joule, clear. So this value in the electron volt we can write, we have to divide by 1.6 into 10 to the power minus 19. So this is equal to 4.9 electron volt, clear. So this is what energy of a single photon, clear. Now we have to find the n value, means flux we have to find, means number of photon per second we have to find, clear. So how we can find this value? So n is equal to, we can see from here, n is equal to intensity, and intensity is what, 0.2, and divided by, we can write, this is what, 4 pi. This is what intensity into, we have to take the area, and divided by, we have to write the energy of a single photon. So energy of single photon in joule we can write 7.84 we can write into 10 to the power minus 19 we can see, clear. So this is equal to 0.2 we can write, clear, into, we can write, this is the 4, this area is what, this area is 4 centimeter square. So 4 into 10 to the power minus 4 we can write, and divided by, we can write, this is equal to 4 pi into, we can write 7.84 into 10 to the power minus 19 we can write, clear, this. Now we have to solve this, and after solving this we can find n, and n is what, number of photon per second. So this is equal to 8.12 into 10 to the power 12 photons per second we can write, clear. So this is the answer for the B part of this question. Now coming to the C part of this question. So in the C part, we can see from here, current we have to find, clear. C part we can see photo efficiency is defined as the probability of the photon being successful in the knocking out the electron from the metal surface. Calculate the saturation photocurrent in the cell, assuming the efficiency is equal to this. So efficiency is equal to this 0.1 we can say, clear. So current is equal to what, efficiency, that is equal to 0.1 into number of photon, that is equal to 8 point, that is equal to 8.12. So this is what, 8.12 into 10 to the power 12 into charge of the electron, clear. So this is equal to 1.6 into 10 to the power minus 19, clear. So this is what, charge per second, because we have taken this n per second, photon per second. So this is equal to what, 65 nano ampere. So clear. So this is the current, clear. So this is the answer for the third part of this question, clear. Now coming to the D part of this question. So in the D part, we can see, in the D part we have to find the cutoff potential, clear. So how we can find the cutoff potential? So for cutoff potential we can use this, E into V naught is equal to H nu and minus work function. This we can use, clear. So from here we can see H nu we have found it earlier, this is equal to 4.9 electron volt, and the work function is, we know, 2.22, and this is what we can write, electron volt we can write. So E into V naught is equal to this, clear. Now from here we can write V naught is equal to, this is equal to 4.9 minus 2.22. So this is equal to, we can write 2.68. We can write 68 volt we can write. This E and E cancel out. So this is equal to 2.68 volt, clear. So this is the answer for the fourth part of this question, clear. So in this way we can solve this question. Hope this answered your question. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubt and App today.